Hello everyone, welcome to my channel Bytes of AI, and today I have arranged a battle between two large language models. This is a battle of maths, and it would be fought between DeepSeek-R1-Distill-Qwen-14B and OpenAI based O1-mini. Before I go ahead, let's see what does it mean by distilled model. So this is the paper by DeepSeek-R1 team, and they have mentioned that to equip more efficient smaller models with reasoning capabilities like DeepSeek-R1, we directly fine-tune open source models like Qwen and Llama using the 800K samples curated with DeepSeek-R1 as detailed in 2.3.3. So this means that they have used the base models, they are open source models like Qwen and Llama, and they have fine tuned those base models with data which has been curated from the most popular uh, open source model, again, DeepSeek R1. That is again a reasoning based model. If you want to know much about this particular model, you can just look into my earlier video. You will get a simplified architecture of this model. So let's go ahead and see how the challenge goes. So let's start with the math test, and before I go ahead, I would like to introduce the files which I'll be using here and also the questions. So this is the function load quant4 OLLM. This particular function I have written to load the open source large language model into 4-bit quantized version. And then this is the O1-mini file, and here I'll be calling the O1-mini model to get the response. And this is just to call the OLLM model. And the first query, or first maths question which I'm going to test with, that is, a caterpillar crawls up a pole 75 inches high starting from the ground. Each day it crawls up 5 inches and each night it slides down 4 inches. When will it first reach the top of the pole? So let's start with the O1 mini model and check how it performs. So this is the question. Yeah, it has written down the answer. So let me see what it has written. To determine when the caterpillar will first reach the top of the 75-inch pole, let's break down its daily progress. Daily climb and slide. Daytime, the caterpillar climbs 5 inches, then slides down 4 inches in the night time. So net gain per day is 5 minus 4 equal to 1 per day. Approach to top. Important consideration. On the day the caterpillar reaches or exceeds the pole's height, it won't slide back down that night because it has already achieved its goals. That's correct. Calculating the days needed. Total height needed before the final climb. Since the caterpillar gains 1 inch each day, it needs to be within 1 day's climb, that is 5 inches of the top before the final day. Very good. Height to reach before the final climb is 75 minus 5, 70 inches. That's great. Days to reach 70 inches at a net gain of 1 inch per day. It takes 70 days to reach 70 inches. Excellent. Final day, on the 71st day, the caterpillar climbs its final 5 inches, reaching a total of 75 inches without sliding back. Wonderful. The caterpillar will first reach the top of the pole on the 71st day. So answer is the caterpillar first reaches the top of the pole on the 71st day. Perfect. Perfect. So now test the distilled model. You can see here I am calling DeepSeek-R1-Distill-Qwen-14B model. And this is the first query. The same question. Here I am loading the open source model into GPU memory. Okay, so it has given the answer. Let's check how it has given. Here you can see that there is a think tag. So within this particular tag, it has thought about the reasons uh, to solve the problem. Let's see how it has thought. First, I need to determine how much progress the caterpillar makes each day. During the day, it climbs 5 inches, and each night it slides down 4 inches. So the net gain per day is 5 minus 4, 1 inch. Since the pole is 75 inch high, the net gain is 1 inch per day. It might seem like the caterpillar would take 75 days to reach the top. However, this doesn't account for the fact that once the caterpillar reaches or exceeds the height of the pole during the day, it won't slide back down that night. Very nice. On the final day, the caterpillar needs to climb enough during the day to reach or surpass 75 inches without sliding back. If we subtract the final climb from the total height, we can find out how much distance the caterpillar needs to cover before the last day. So subtracting the final climb of 5 inches from 75 inches gives 70 inches. At a net gain of 1 inch per day, it will take 70 days to reach 70 inches. On the 71st day, the caterpillar climbs the remaining 5 inches and reaches the top without sliding back. Therefore, it takes the caterpillar a total of 71 days to first reach the top of the pole. So, the model has thought correctly. Let's see what it gives in the answer. To determine when the caterpillar will first reach the top of the pole, let's break down the problem step by step. I'm not going through all the details. You can see here, and then finally this is the calculations. Total height to climb 75 inches, then climb required before the final day is 70 inches, and then days to reach 70 inches is 70 days. On the 71st day, the caterpillar climbs the remaining 5 inches to reach the top. So conclusion is it will take the caterpillar 71 days to first reach the top of the pole. Perfect. So for the first question, I think both O1-mini and the distilled model of DeepSeek-R1 has performed perfectly. Now let's try the second question. So second question is a little bit senior level, and the question goes like this. Two standard dice are placed on a table with one on top of the other so that only 9 of the faces of the dice may be seen. The touching faces have the same number on them. The sum of the numbers on the visible faces is 33. What is the number on the touching faces? This is an interesting question. Let's see how both the model performs. So I have to just change this to query true for both the model. And let me again start with the O1-mini model. So it has written the question here first. Let me see the answer. So first it is again trying to understand the problem based on the reason. So standard dice properties. Each die has 6 faces with number from 1 to 6. On a standard die, opposite faces sum to 7. For example, 1 is opposite to 6, 2 is opposite to 5, and 3 is opposite to 4. Wonderful. I think they have probably cracked the questions. Stacking the dice. When 2 dice are stacked, the touching faces must show the same number. total faces for two dice, 2 times 6 equal to 12. Since the dice are stacked, two faces are hidden. Good. Visibility. The problem states that only 9 faces are visible. Therefore, 12 total faces minus 3 hidden faces equal 9 visible faces. Good. Sum of the hidden faces. Now, the sum of all numbers on two dice is 21 times 2 equal to 42. Given that sum of the visible faces is 33, the sum of hidden faces is 42 minus 33 equal to 9. That's perfect. Then setting up the equations. Let x be number on touching faces. The hidden faces consist of two faces with the number 1 on each die and one face on the bottom die, which we'll call y. Since the opposite faces of a die sums to 7, so y equal to 7 minus x. The total sum of the hidden face is 2x plus y equal to 9. Then substituting from the opposite face property, 2x plus 7 minus x equal to 9, x plus 7 equal to 9, x equal to 2. So the number on the touching face is 2. The answer is correct here, and reasoning is also correct. Let's see how the distilled model performs. Here the question goes. It has given the answer. Let's check how it has performed. So we'll first go through the thinking process of this model. So first I recognize that when two standard dice are placed with one on top of the other, only 9 faces are visible. The touching faces have the same number and the sum of the visible faces is 33. Each die has 6 faces and each face is labeled from 1 to 6, and the sum of all the faces on a single die is 21. For two dice is 42. Since the touching faces are hidden, the sum is twice the number on the touching face, which I'll denote as x. Therefore, the total sum of all visible faces is 42 minus 2x. The problem states that the sum of the visible face is 33, so I can set up the equation 42 minus 3x equal to 33, solving for x. 42 minus 33 equal to 2x, 2x equal to 9 and x equal to 4.5. I think they have gone wrong here, because so two dices have actually 12 faces, and it has clearly mentioned in the question that there are 9 visible faces of the dice. So two dices are there. So bottom dice, one of the face will be on top of the table, so that is also hidden. So there are actually 3 hidden faces, and 2 other faces which touching each other, those are also hidden. So 2 plus 1, 3 hidden faces. And it has also clearly mentioned here like 9 of the face of the dice may be seen. And here they have just considered or thought, like, since the touching faces are hidden, their sum is twice the number of the touching face. That is okay. I'll denote as x. Therefore, the total sum of all visible faces is 42 minus 2x. 2x are the touching faces, but they are not considering another face, which is actually facing the table. That is the face of the bottom die, which is facing the table. That is also hidden. They are not considering that. So I believe, x equal to 4.5. And since the number on a die must be an integer between 1 and 6, there is no valid integer solution for x. This indicates that the given conditions are impossible under the standard numbering of dice. And let me see at the bottom what is the answer they have given. Okay, they have given 4.5. and which is wrong. The correct answer is 2, which was given by O1-mini. So to conclude, I would say that battle has been won by O1-mini, and I'll also say here for the distilled model, it is not the direct replication of DeepSeek R1 because it is kind of fine-tuned model of the Qwen 14 billion parameters. So, and also I have loaded the 4-bit quantized version of that. So maybe some of the precisions have been missed out here, and but I don't think that that is causing any issue. But clearly, distilled model probably is not as performant as the DeepSeek R1 model. Though I could not taste that model. I could not load. That is a huge model. I'll not be able to load it here, but definitely I'll give a try later on to check how does it perform, whether it can give a proper answer to these questions. With that, I can say that O1-mini is still a better performer in reasoning-based model, and this distilled model probably not at par as they suggest in their paper. Let me check. So this is the evaluation of all the distilled model, and you can see that 14B Math 500 is given like 93.9 score, whereas for O1-mini the score is 90. But definitely in this particular situation it has failed. So that's all for today. Please do like, subscribe and share, and do not forget to leave your comments. Thank you for watching.